Hello, this video is designed to give you an overview of the primary programming tools we are planning on using in this class. I hope that watching this video will give you a high-level understanding of how the tools work and why we chose them. I don't think that most people actually want to learn how to program a computer. In an ideal world, we would just tell our computers what we want and sit back and make them figure out the details and do our work for us. Unfortunately, the computer can't actually speak English. Instead, the heart of a computer, its central processing unit, speaks in ones and zeros, which is also called binary or machine code. In order for us to talk to the CPU, we need to use an interpreter. We tell the interpreter what we want to do, it translates our commands into machine code. The CPU executes the code and communicates back to the interpreter the results, which is then translated back into something we can access. The commands we send to the interpreter are not exactly English, but they sort of look like English. There are lots of different programming languages that can be used to send commands to the CPU. Each of these languages have their own interpreter or compiler that converts the programming language into machine code. Although all the languages do the same basic thing, there is no one best language. The different languages are designed for different reasons and have different strengths and weaknesses. It is key to note that they essentially do the same thing: communicate what you want to do to the computer in a way that is understood by both you and the interpreter. For now, let's not worry about the CPU and the machine code. Although this is an interesting topic that can help you understand how to program better, let's just treat the interpreter as a black box. We give it commands in our programming language, and output comes the results. The programming language we have chosen for this class is called Python, and the interpreter for the language is called the iPython interpreter. Like I said before, this language has both good and bad attributes. However, it is a modern language designed for doing scientific code quickly, has lots of tools you can leverage, and has a very low barrier to entry, making it an ideal language for an introductory programming class. There are also some limitations to Python, but we can talk about those later. Let's do a quick example on my computer. Follow along if you have Python installed. The first thing I'm going to do is open a command window or terminal window on my computer and then type Python, followed by the enter button. This will start the Python interface. You should see the Python prompt, which is just 3 greater than symbols in a row. Once the Python interface starts, we can type some commands using the keyboard. These commands get sent to the Python interpreter, and the results are sent back to and displayed on the screen. To exit Python interface, we just type the word quit, followed by the open and close parentheses. You don't have to type the commands every time you want to do something. You can store the commands in a text file and pass that file to the Python interface, which then executes the commands line by line. For example, I have a file here called example.python. It's basically the same commands I just typed. And if I type Python and pass it in example.python, I get the output I want. Although the original Python interface works fine to communicate with Python, there are actually many different interfaces you can use. For example, a newer interface is called iPython. I can start the iPython interface by just typing iPython at the command line. The iPython interface has a lot of little tweaks that just make it easier to use the interpreter. For example, the interface has a help menu. You can see it by just typing help followed by the open and close parentheses. The help menu is really nice because it helps you through the iPython process if you don't remember commands. You can exit the help menu just by hitting enter. The interpreter also keeps track of the history of what commands you've typed. You can use the up and down arrows to cycle through all your commands and reuse them just by hitting enter. This is really nice since you don't have to retype everything. Both the Python and the iPython interfaces communicate with the user, that's you, with a keyboard and screen using text. These types of interfaces are commonly called command line interfaces, or just CLI. However, as you probably already guessed, text-only communication is fairly limited and can be slow. When working in science, we don't want to see rows upon rows of numbers. Generally, it is much better to display our data using graphs and charts. For this reason, there is a whole class of interfaces called GUIs, or graphical user interfaces. An example of a Python graphical user interface is called Spider. You can start Spider just by typing Spider in the command line. Here's an example of the Spider interface. On the left-hand side, you can see the Python commands that are stored in a file. On the right-hand side, you see iPython command line interpreter, and there are lots of other tools designed to make communicating with Python interpreter easier. I can run the commands just by hitting this play button, and I'll see the results here in the Python window as a graph. So, as you can now see, there are a lot of different ways you can communicate with the Python interpreter. The different interfaces were designed for different reasons. All have their purposes. In this class, we have chosen to use yet another interface called Jupyter. As you learn to write Python code in Jupyter, I hope you will remember that there is more than one way to run your program. Sometimes just changing which interface you use can open up new possibilities for problems you can solve. One neat thing about Jupyter is it uses a standard browser interface to communicate with the Python interpreter. The actual interpreter can be running on a completely different computer than the one where you are writing your program. This makes it so you could even access the Jupyter interface through a tablet or a phone. The Jupyter interface uses a concept called cells. There are different types of cells. There are markdown cells, code cells, and other types of cells. You can execute the code inside a cell by hitting the Shift key and holding it down, and then hitting the Enter key. You can also hit the Run button here on the button bar, and that will run the code inside the cell. And as you can see, the Jupyter Notebook is a graphical user interface, and the graph that I generated with my code also appears in line with my code. We will be using Jupyter Notebooks throughout the class as an easy way to give you assignments and let you turn in your results.